So the Gauss-Jordan method is the reduced row echelon form. I'll just, I'll just show you where that is. You probably already know where it is, but I'll go back to sharing that view again.
I was on this a while ago, but it was like a few weeks ago, so I just need like a refresh.
Right. So if you go to your matrix again, under math, the most of the stuff you need is going to be here. Like you might be doing a few determinants in your calculator. But if you go down to RREF, that's your reduced row echelon form.
Okay.
That's the one that solves most of these. And that's the one you're going to want to look at most of the time there.
Okay, so I just do that, right? And then I plug in which matrix, correct?
Yes. And so your matrix needs to have all the rows and the columns, meaning like anything in front of X, Y, Z, however many variables you have, and the right-hand side and the equal sign.
Okay, so it's all of it.
It's all of it, yeah. And if you don't have a variable, you put 0 in. You double check that you've entered it correctly, because that's where most of the mistakes are made, are entering it, not in the actual, like anything else. It's just getting in the calculator right.
Okay.
So I'll put that here again, second matrix, math, and then RREF is the one you're going to use most of the time.
Okay, got that. Okay, simple enough. Okay, so the next thing I have is inversion and determinants.
Okay.
These can be done on a calculator too, correct?
Yes. So let me go back there. So let's just say like take a look at 7A. Do you see that one there?
Yeah.
Okay. I'm going to enter that one into the calculator and show you how to do that. Let me do a new share here. All right. So I'm just going to quit out of this. I'm going to go to second matrix again. I'm going to edit and I'm going to change the size first. So I'm going to do a 2 by 2. You always have to set the size first. That's row by column. So this is -1 and then 2. I'm just following the ones that was given in your review pack. -1, -2. Okay. And then very important is to quit out. If you don't quit out, you run the risk of actually like doing something strange with it. So first for determinant, second matrix, math, number 1, that's the determinant.
It's just, gotcha.
And then you have to grab the matrix second. Like you're used to maybe grabbing the matrix and then doing something to it. Here, it's a little wonky. I mean, we would never do this now. The calculators aren't very sophisticated, but they once were. So this gives you the determinant, gives you a number.
Gotcha.
Now the inverse, okay, of a matrix is actually done by first grabbing the matrix again, and then this button right here, this -1, that'll give you the inverse of it right there.
Okay.
Now, if you don't like decimals, you can change that into a fraction by hitting math, enter, and that'll convert it to fractions there.
So you did math, enter,
math, enter. I'm going to try and write some of these down so that you can have them enter. That gives you fractions.
Gotcha. So
your world in this exam is second matrix. You're first editing them, making them whatever you need, and then you're using some of the things here, like we already talked about, determinant, and then transpose, and then I showed you RREF. Okay, and then sometimes you go and you use the -1 for inverse. That's the one under matrix, or it's the matrix button there, that -1.
Gotcha. Perfect. And then Kramer's rule, once again, you can use a calculator, correct?
You can, but you have to set up the matrices this time before you can do it.
Okay, yeah.
And like, I don't thought, like, there's so many online calculators now. Like, if you haven't done this in a while, I'm happy for us to work through a few of them if you'd like. But like it says here on the review, go back to question 11, A, B, and C, and do one of them using Kramer's rule. Would you like us to do that now?
Do I use the numbers on the other side of the equal sign?
They replace the, like, if you're doing dx, they replace dx. If you're doing y, they replace dy.
Okay, wait. Then yeah, maybe go through 11.
Okay, let's do that. So I'm going to snip that in. I'll share that screen here.
I know these are super simple, but just
Well,
making sure.
yeah, but this is really important for you. I'm sure you got, plenty riding on this. So let's make sure you get it down so that the next time, it makes the next exam even easier because you don't have to get as high a grade on
Yeah,
it. So
that would.
I'm all about doing whatever you need. This is totally about you. If you get a good grade, that's the best part here. So the Kramer's rule says that x is dx over d and y is dy over d. And d is the determinant of 3, 6, 2, -1. Like it's a number. And so is dx, but it's this side. You remember that from class? Is that
Yeah, I just
clear?
needed. Yeah, my confusion was like, what ones do I use the other side of the equal sign, and what ones do I not?
Okay. So so when you're doing dx, you replace the 3 and the 2 with the 3 and the 7. Because like you just don't use those. I mean, there's some background to this that doesn't matter, but that's you just need to know what to do, which is
I remember
get the
this.
determinant of this.
Gotcha. Okay. Yes. And then I find the determinant of x and y, and then that would be my like.
Yes, and then you do the same thing for dy. Instead of the y's, you use the right hand side. So it's 3, 2, 3, 7, and you get the determinant of each of these.
Gotcha. And those give me single numbers, right? Or
they all give you single numbers. The determinant always results in a number.
okay, so the answer is just going to be like an XY thing, like a coordinate type setup.
It is, but like this bottom number here, you're going to get two numbers, then you divide them to get x. Two numbers divide to get y.
Oh, okay.
I mean, we can do these right now if you want. D is 3 times -1 minus 6 times 2. So -3 minus 12, which is -15. Dx is 3 times -1. You do diagonal minus 6 times 7. So it's -3 minus 42. So that's -45. So -45 over -15 is 3. That's totally reasonable. And then dy here, 3 times 7 minus 2 times 3, 21 minus 6, that's 15. So again, it's 15 over -15. Y is -1.
Gotcha. Okay.
If you would like me to go through that again, I can. They generally work out nice.
Yeah, that was simple enough.
Now, one thing you can do in the exam is you can solve this using RREF and then just kind of show what I just showed without actually doing it, because they're just looking to see, like, did you kind of do the work?
Gotcha.
So if you just show the three matrices and then you write down the answers, I mean, you probably get full credit. Like, you can solve it however you want. It's just the work has to indicate the method that they want.
Gotcha. All right. That's easy.
All right. So we did some Kramer's, did one of those. Do you need help with a problem like 14 setting up the system to solve?
I don't think so. That's pretty straightforward. Yeah.
All right.
That one's fine.
Okay.
Where I have an issue is like now where we get into like probability for some reason. I don't know why they just don't click.
Okay. Which one? I'm sorry.
I guess we'll just start at 15.
15. Okay. So we're talking about set stuff. And just in case you, you didn't know this already, you're never going to use this again. This is such a math
Well, I don't
specific thing. Um,
doubt it.
but you have to know it for this exam. But I'm prepared to just tell you enough to get you through this exam because that's all you need. So
Okay.
if that's motivation enough to just learn it for the short term, two symbols you need to know. This one means or both, basically. So
Mhm.
when it says A or C, you're saying it can be in. That means it can be in one or the other or both.
Okay.
Okay, and then this N means we're counting. So like there's really two things here. It's like, well, what's in A or C? And so you just count like how many elements are A? Well, there's 1, 2, 3, 4 elements in A. How many are in C? Well, there's two more, but there's one duplicate, so you don't count it. And so that gives you the fifth one.
Gotcha.
Okay, so that's how you come up with that number there, right there. Okay,
Okay.
now this tick, that's not great. So tick is B tick means everything not in B.
So just A and C.
It's not referring to A or C, it's referring to the names that are not in B. So let's go up to S. Okay. S contains all these names. B contains all these names. So if it's not in B, I'm going to circle it. So see how Arthur is not in B?
Okay. Gotcha.
Dirk is not in B, but Franz is. So we ignore that one. Okay. And then Henrika is. So that's, and then, but Johann is not. God, these are weird. Okay. Klaus is there. Sari and Tina. Okay. So there's three elements that are not in B. That's what that means. Like B not means the set that includes Arthur, Dirk, and Johann. That's what B tick means.
Okay.
Is that clear? Because that leads to the next stuff.
Yes, that makes sense.
Okay. This upside down U means and.
Mhm.
Must be in both. Must be in both. So A and B tick. So it has to be an A. So Dirk, Franz, Johann, and Sari. So let's go A. So A is D, F, J, and S. So what's in both? That's in both, and that's in both.
Gotcha.
So how many are in both?
2.
Two.
Okay.
All right, now to do the last one, I'm actually gonna snip this down and reset here. I know you don't have that option in the exam, but there's just too much going on here when you get to this point. So this says A or B, and then you tick it. The instructor might have shown you some like rule where like you can change it. But let's just look at it literally. A and B. So what's in both A and B? Franz is in both, and Sari is in both.
Okay.
So A and B is the following. It's Franz and Sari. That's what A and B is. Okay. Now when we tick it, oops, let me do that in line below. When we tick it, that means everything that's not in those. And it's referring back to this initial set. Okay, so how many are not, basically if it's in, you cross that out if it's there.
Gotcha. So
So you have so that leaves 1, 2, 3, 4, 5, 6 that are not in that. And
gotcha.
that's what it's looking for, number 6.
Okay. Gotcha. That's easy.
Do you think you can reproduce that on the exam if you needed to?
Yeah.
Excellent. Okay. Should we do 16?
Yes. Sorry, I'm just writing something down real quick.
Okay. Sometimes I go too fast. Just tell me, Matthew, slow down. Again, you're going to get this at the end. You know, but I forgive me for going too fast.
No, you're all good. Um, okay. So yeah, 16, might as well try it.
Yep. So 16 says if the number of elements in A is 50, the number of elements in B is 40, and the number of elements in A or B, that's what that means, A or B, is 80, find this other thing here. So whenever you have two things, that's a Venn diagram. So two things always leads to a Venn diagram. Classic, exam problem here. Okay, so there are 50, let's call this A and let's call this B. The or is like all of this region in here.
Okay.
Okay, and unfortunately I got to undo all that because it's going to be bad for us when I try to put these in there. So like we don't know how the number, but there's three numbers here that add up to 80. We know that A is 50, but that's this whole thing here.
Gotcha.
So the way you start here is you take this 80 and you subtract 50 and you get 30. So there's 30 there.
Okay, gotcha.
Actually, let me back up. This is not the best way to do this problem. Let me back up here. You probably saw this formula in class that it said number of elements in A or B equals the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Did you see that in class?
Yeah.
Okay. And this is where you actually don't even need this diagram. Sometimes they make you fill that in, but I was jumping ahead to something that's unnecessary. So this is 80, this is 50, and this is 40. Excuse me, minus, and we'll call this is X. So you just have to solve for X here. So you can see that X is 10.
Okay, wait, didn't they? Oh no, I don't know.
So let me actually get rid of all this, which is unnecessary.
Yeah, I thought.
I was making this more complicated, and I'll move all this up.
I see. Wrong.
See if this is a little bit more clear. So once you have the formula here, it's pretty straightforward. Are you doing this in WebAssign, or is it on paper? What do you have going on?
It's on paper.
Okay, so probably won't be. It might be like this, but this would be a short question.
Okay. I just had my numbers wrong written on my sheet, so I get what you did there. You're solving for X. Yeah. Okay. Simple. All right.
Okay. Do you want us to move on to like 17, 18, 19? The whole thing about the Venn diagram actually comes up again in 24, 25, but we can see if we get to that.
Okay. I get 24 because that's like literally what we just did, right?
Mm-hmm. Yep.
And 25, it's 25. It just, I guess it's figuring out which one's A, B, and the A or B.
Yeah, you want to fill in the Venn diagram in 25, and you start in the middle if you can and work your way out.
Okay. So
and I can work through that here.
Yeah, we can do that one.
Okay, according to a weather service, there's a 75% chance of rain in New York and 30% chance of rain in Honolulu. There's also a 10% chance that it'll rain in both cities. So both is the intersection, and the intersection's right in the middle. So that's point 1. And if this one's New York and this one's Honolulu, that's where I was going with the previous problems. You take that 0.75 and you subtract the 0.1 because you subtract out the both.
Gotcha.
And then you do the same thing with them, 0.3 minus 0.1, and that's 0.2. And you should always check this. You should, okay, well, is 0.65 plus 0.1 75% chance? Because that's what that circle represents without the other one. And then 0.1 plus 0.2 is that 0.3. Yes, that's what it adds up to. Now it says all 4 regions, 1, 2, 3. Oh yeah, there's this one on the outside. So you have to add up those three numbers, 0.65 plus 0.1 plus 0.2. That equals 0.95. And there's something left over to get to 1, and that's 0.05.
Okay, so the outside portion.
Yes.
Gotcha.
And that's what that means by I must add up to 4 or add up to 100%. You want to get all those numbers before you start answering questions, because more often than not, you're just going to be either getting a number or adding up a number.
Okay.
So neither is that number right there.
It's the outside portion.
Yes.
Gotcha.
Exactly one of the two cities. I'm going to draw the crescents. It's that one. Sorry, it's horrible drawing. And then it's that one there. So it's the 0.65 and the 0.2, but you have to add them together.
Okay, that's easy.
You will probably get one just like this on your exam with different numbers.
Okay, yeah. Easy. Yeah, my professor does not explain things very well. So I like never understood, like I would have never known any of this, like what to do with it.
Yeah, it's just a struggle in college. You got, they're maybe English is their first language, or they're going so fast, or they, they're acting like they've done this so many times. But as a student, you might be seeing this for the very first time. So you're just trying to catch up. Did you already take Math 210?
Yes, I took it last semester.
Excellent, excellent. Okay. Well, you're probably almost done with your math requirement.
Yeah, I don't think next semester I maybe have one more. I don't have to take it.
Might have to take a stats class at some point, but
Yeah, I think that's what I'm taking next
pretty much
semester.
on your way.
Looking forward to that, but
Well, I'll definitely be available to help. How are we doing for you tonight, though? Are you getting everything you need out of this lesson? We're about halfway through.
yeah,
Make sure you're getting everything you need out of it.
yes, you've made everything like make sense. Not that this is super difficult, but like since I didn't even like understand what we were doing in the first place.
Understandable. Where should we go from here? So we skipped over a bunch of problems, 16 or 17 through 22, 3. Do you want us to go to 27? Oh, we're actually almost all the way through.
Oh yeah, the permutations and combinations I'm confused on. So I'd be like 17. Yeah. 17.
17, excellent. Okay. $17. Okay. I call this this is kind of a before you get to combinations and permutations. It's I call it more of like a bucket or a counting problem, because it's like there's these buckets or bins that you choose from. So it's like, this is appetizers, this is soups, this is main courses, this is desserts. Okay. But there is a little bit of this because you have to choose between a dessert and an appetizer. So let's just put the numbers here: 5, 5, 6, and 6. Okay. So if you just had to get if you had to get one of each, you would just multiply the numbers. Do you see that?
Yeah.
Okay. Like if you had to get one of each, you just 5 times 5 times 6 times 6. Okay. But it doesn't say that. It says you have to decide. You're either getting a dessert and an appetizer. So here's the possibilities. You either go app, soup, main, or soup, main, dessert. Do you follow that? Is that clear?
Yes.
Okay. So if you go app, soup, main, that's 5 times 5 times 6. And if you get soup, main, dessert, that's 5 times 6 times 6.
Okay.
In math, or generally means plus.
Gotcha.
So we'll just go with that here.
Okay, so it's just 330.
Yes.
Okay, that's really simple.
Yeah,
took
I
a
mean,
quiz today and made a problem just like that, and now I'm realizing I did not do that correct. So that's great.
well, if you had WebAssign, there's a few variations on this question. There's some, some very strange ones, but these seem a little more straightforward.
Yeah, I'm hoping on the test that as straightforward as the study guide. Okay, so that's easy.
How about like a 19 or 20 is where you start with permutations and combinations.
Okay. Are 18 and 19, would they be solved the same?
18 is different. 18 depends on how many duplicate letters you have.
Isn't that where the exclamation mark thing comes
Yes,
into
yes,
play?
yes.
Okay.
It won't take long to do all either any or all of these. So let me just snip it in, and
Okay.
The shortcut here is to remember that it's the number of letters factorial, okay, over, and then you're looking for duplications down here on the bottom, factorial. So an example will help. So chosen has 1, 2, 3, 4, 5, 6 letters. So for chosen, it's 6 factorial up top. Are there any letters that are duplicated on the bottom?
No.
No. So it went at being 1 factorial, 1 factorial, 1 factorial 6 times, but 1 factorial is 1. So it just becomes 6 factorial.
Gotcha.
So it's not, that's not particularly helpful, but we'll do, so 6 factorial is 720. So we'll do elephant next year, elephant here, PHANT. Okay, there you are. 1, 2, 3, 4, 5, 6, 7, 8 letters. So that's 8 factorial. Are there any duplicate letters?
Yes.
E and E. So that's there's 2 E's, so you put a 2 factorial in the bottom there.
Oh, gotcha.
Okay, so that affects this. I actually don't know what 8 factorial is, but it's you got to. Do you know where this is on your calculator? The factorial button.
Yeah.
Okay, I would absolutely do this on your calculator. I would not even try to do
No.
this by hand if you didn't have to.
Gotcha. Yeah. Okay, that's easy. We don't have to do
Okay,
the
and then the
first.
last one. So this ends up being 20,160. The last one is excellence. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 factorial over. E's duplicated 4 times. So that's a 4 factorial. L is duplicated. So that's that's a 2 factorial. And I don't see any, oh, C is duplicated again. That's 2 factorial. So that's for the E's, that's for the L's, and that's for the C's.
Gotcha.
And then if you're doing this in your calculator, make sure you put parentheses down here in the bottom or you'll get a completely wrong answer.
Okay. Gotcha.
You have to know this formula. Again, you don't need to know why it works, just know that it works for this problem.
Okay. Gotcha.
Okay,
Simple.
can we go to, you said 19. Is that right? Yes, 19.
Yes.
A 6-digit password is to be formed from the digits 0 through 9. So that's 10 total. You should always count to double check because it really matters. How many different passwords are possible if digits are repeated? So again, like I think of these as buckets, like each one is the digit.
Okay.
So how many numbers can go in the first position? 10. And if you can repeat, that means that you don't lose any. Like it's not like you pulled it out of a bag and it's off to the side. So it's 10 again, 10 again, 10 again, 10 again, 10 again. So for part A, because they're repeated, like you don't worry about duplications. That equals 10 to the 6th.
Okay.
For part B though, it's like pulling them out of a hat or out of a bag. So yeah, you got 10 to start, but you pull one out. How many are left over?
9.
And then you do the same thing. And this is what kind of leads into permutations. It kind of is a permutation, but I think this is clearer to try to look at it as a bucket problem, or, how many, you fill in the numbers and then you multiply this. So this is 10 times 9 times 8 times 7 times 6 times 5, whatever that is.
Okay, so why wouldn't you add in the 4, 3, 2, or
Because it says 1, 2, 3, 4, 5, 6 digits.
Oh, okay, yeah.
And you stop right there. Like, maybe you get a problem where it's 7 digits, then you got to add another one, or it's only 5.
Gotcha.
On the exam, sometimes you get these words like, it's like the first one is a letter. So there's 26 letters, could be, sometimes they say you can't start with a 0. So there's only 9 here, but that's, there's just a few little variations.
Okay, simple.
Okay, I'm going to do 21 first because 21 tends to come before 20 in terms of learning. So I think it'll make more sense. And I'm going to tell you what it is. I'm going to tell you this is a permutation, and we're going to talk about why it's a permutation. And that's because order matters. And order matters because, let's say first place pays $1 million and second place doesn't, you want to be in first place because you get the prize. So try to think of it in terms of like, would it really matter if I was in first versus second, or first position versus second position?
Okay, and then isn't it, if it's not in order, you use the C1?
That's right. So this is 30P5. This is 30 is how many you're choosing from 30 people, and this is the number of positions.
Okay.
But in truth,
how do I know which one goes first? Like
the bigger number.
The bigger number goes first?
Yes, always.
Gotcha. Okay.
It's rare. So just though, this is actually still a bucket problem because 30 people can be first, and then someone's first, so there's only 29, 28, 27, 26. If you were to do this, multiply this out and do this in your calculator, you get exactly the same thing.
Okay, perfect. So I'll just stick that in my calculator.
Yes. Okay, but it's like that was a good question asked because it is always the bigger number. That's just the way it's going to be. And it's a good shortcut for this exam that you're doing.
Okay, perfect.
So question 20 is next. This is a combination problem, although it's not written well. There are some lotteries where order does matter. This is a combination. So it's like saying it doesn't matter. As long as you get all 6 numbers, it doesn't matter whether you chose that first number, as long as it appears in the deck or in the sequence. Sorry if that was confusing. It's like A, B is the same as BA because you're looking at it as a group.
Gotcha.
And so again, like you just said, the bigger number comes first, smaller number comes second. This is what you're choosing from. This is how many you're choosing. The number choosing. But it's always true. What you just said.
Gotcha. Okay, that's easy.
Are you comfortable finding that on your calculator, the C and the P? Okay. Great.
And then, we don't have to do 27, 28 because he didn't teach us that, so he's not putting it on the test.
Okay.
Oh, we actually went through the whole thing.
Yes. We have some time left. We have 10 minutes left, a little bit more if you need. Why don't you look this over, see if there's anything else here you'd like us to cover, other examples.
Okay. So for number 8, it says for each matrix in problem 7, state if the inverse exists. If I just plug those into my calculator, would I be able to figure that out?
Yes, but you have to know what to look for. So let me snip this in and give you what you're looking for. There is a shortcut, but we'll go with this. So you may, if you get a number, that means it exists. If your calculator says error, there's 2 possibilities. You made a mistake in entering it, or or it actually does not exist. So make sure there was no mistake in entering it. And then if you get an error, that means it does not exist.
Gotcha. That's easy. Perfect. Number 12, is that like what we did in 11 with like,
This is a pure definition. It will not be on the exam, but you may have to use it. So the in like what are called linear algebra classes, they really emphasize the order here that matters. And the order here that matters is, looks like it's this one. All the other ones are just not correct.
okay.
It has to do with the order that you put the inverse matrix. It has to be in front of the other one. Doesn't matter for what you're doing. I wouldn't give this much thought.
Okay, that's
because you're gonna use your calculator anyway.
Gotcha. Yeah, I think, I mean, we went over all of it for the most part, and yeah, probability is not hard at all, just the way he explained it. Because I was like, I know I've done this before, and it was never this challenging ever.
Yeah, if you took a standard set of high school classes, you've seen everything on this exam.
Exactly. That's why I was like, when he was explaining it, I was like, there's no way this shouldn't make sense right now.
Yeah, good way of thinking about it. All right. So if you don't mind, are you a referral from someone?
Yes. Elise Jones.
Elise. Okay. Well, thank you so much for scheduling. My phone number is listed. If you ever need a lesson time that isn't available on the website, just text me. Like if you got a work conflict or school conflict, I do my best to try to accommodate, as much as I can. So if you can't get a time you want for next time, just text me and be happy to help. So I'll send you the notes and the link to the screen recording, and I guess best of luck on the exam.
Will do. Thank you very much.
You're welcome. Have a great night. Bye now.
Bye.